In this video, I will demonstrate the solution to this bullet, where we are looking for the probability that x falls between two values. So, as a result, we must compute two z-values. Draw your curve. X mean is $441.84. Standard deviation is 90. We want probability that x falls between $350 and $500. We mark those on the x-axis. Of course, we realize 350 is a number lower than the mean, so it must appear to the left of the mean, and 500 must appear to the right of the mean. To compute the z-values, we know the mean has a z-value equal to 0. The 350 and 500 equivalent z's are, I'm going to write them as z1 and z2. If you compute them, you get 350 minus 441.84 divided by 90, which we found in an earlier video to be negative 1.02. Z2 is computed as 500 minus 441.84 divided by 90, which in an earlier video we found to be positive 0.6462. However, we rounded that to 0.65 because the normal z and standard normal z table lists z-values to 2 digits, to 2 decimals. So we will be looking at these two numbers. Because I have shown these in an earlier video, I will not show you the z-table now. We will just be looking at and working with those two numbers. From the table, we know that the area to the left of, all the way to the left of 500, or the area to the left of 0.65 z-value is all this is 0.7422. We also know that the area to the left of z of negative 1.02, or this area, is 0.1539. Therefore, this overlapped, this area that is now in green must be subtracted from this total area to the left of 500 to show us this, or to give us this shaded area that I'm shading now, dashing with red colors. So that is the answer to this problem. Probability that x is greater than 350 and less than 500 is equal to the probability that z is greater than negative 1.02 and z is less than 0.65, which is 0.7422 minus 0.1539, and the answer is I don't know what that answer is. I don't think I have computed it. And that answer would be 0.7422 minus 0.1539, which is 0.7422. 0.5883. 0.5883. To do this in Excel, you would compute two normal distribution tables. You would put equal, and first you do the bigger probability. So you would compute this probability from 500 and lower. So this would be equals norm dot dist of 500, comma 441.84, comma 90, comma true, minus norm dot dist of 350. Yes, the number was 350 that we used, comma 441.84, comma 90, comma true. And I can go to Excel now and perform that calculation for you. Actually, I need to put a less than sign here. Okay, so equals norm dot dist 500, comma mean, comma standard deviation, comma true, minus norm dot dist of 350, comma mean, comma standard deviation, comma, and then I can put either a 1 or a true. It doesn't matter. It does the same thing. And if I enter, I get 0.5871. I believe I answered 0.5883. 0.5883. Using the table. So you can see that there is a slight difference, and again, as I've said in my prior videos, it's all due to rounding and the fact that we use only 2 digits for our z-values instead of the exact z-value. The next two videos will be using norm inverse, or we'll be using the normal distribution inversely. We will be looking for values from within the table and then work outwards to find a z-value, and that will be used to compute an x value in our calculations. Thank you for your attention, and I hope you have found this to be helpful.